So now we will see full wave AC voltage controller with R load. Full wave control. So it means the positive half cycle is going through the T1 and the negative half cycle is going through the T2. And you have the alpha here. You have alpha also here. So you can see here, this is the apply input voltage, right? The full cycle, positive half cycle, negative half cycle. So positive half cycle is going through this T1. So you can change the phase angle or the delay angle at any time. So for example, I trigger here 30 degree. I apply the trigger signal only at 30 degree because this is 0 to 180 degree. And so this is, I can control the positive half cycle. The negative half cycle is going through this another thyristor instead of diode. The previous one we saw here diode. So here we have the SCR, so I can apply the gate signal and control the delay. It means I can control the width of this signal. This is the positive cycle and this is the negative cycle. So everything else is the same. All the operations are the same. And the current is flowing through the load resistor, and then of course it will fulfill the law. And it will just go through the source again. So it means the circuit is complete for the positive half cycle and also for the negative half cycle. So for the negative half cycle, it will flow through this way. Okay, so load power can be varied by changing alpha over the full range from 0 degree to 360 degree. In the previous circuit, we have the control only in the first 0 to pi, 0 to 180 degree. But in this circuit, we have the control over the entire cycle, the full wave. That's why, for example, from 0 to 360 degree. That's why we call this as a full wave AC voltage controller. So finally, if you make the average, then of course, you will get much lesser value than the previous circuit. Here you are controlling only the positive side, the negative side is the same because of the diode. So now we know this, and this is the formula for this full wave controller. In the full wave controller, I am not going to derive. Actually, you can derive by yourself. This is very simple. The logic is the same. So you always have to see what is the limit. For example, here where we are now, full wave. Full wave means the conduction is 0 to 2 pi. But in the it means you can control the alpha value from here to here. So that is why we have here RMS value is square root of 1 divided by pi, alpha to pi, and this is the input voltage, and you are making square. And this is the standard formula to remember. And RMS load current, that is IORMS. It means this is the output current is flowing through here. So RMS value of the output current, that is this one, VO divided by R. So VO is nothing but a VO RMS. So this is the VO here is between the voltage drop across the resistor, that is the VO. This is the RMS value of the output voltage. Okay, so single phase full wave voltage controllers are more suitable to practical circuits because you have more control. It also overcomes the problem of DC component, which is present in supply and the load circuit. Okay, here in the half wave circuit, you have the DC component. You know, we have studied about harmonics, AC harmonics, DC harmonics. So here we are studying about AC to AC controller. So in this AC, you have the DC harmonics because of only you are controlling half cycle. But in the full wave, we don't have such a problem. So because you are controlling both cycles, half positive and half negative. So you can balance it. You can avoid this unwanted DC component in the output. And instead of having two different ACR or two different thyristors, you can use one single device that is called a triac. Triac is one of the several thyristors. So this will be like this. It's just a single component, and it will have only one 3 terminals. So here we have the positive terminal, and here we have the negative terminal, and here we have the gate terminal. So the positive half cycle will pass through this this device, and the negative half cycle is also going to pass through this device. It means you can control both positive half cycle and also negative half cycle. It's exactly same as the full wave, but here we can control, this is not half wave. So this is, you can control the entire input voltage at the output. It means you can change the alpha value between 0 to pi and also between pi and 2 pi. So it's everything, operation is the same. So far what we had seen, half wave AC to AC, full wave AC to AC voltage controllers with resistive load.